Hello, everybody, and welcome to the Meet Your Mentor podcast. My name is Elise, and I'm going to be your host for today. Just a little bit of background about me. I am currently almost done with my sophomore year in high school, and I'm interning here at the Mentor Project, which I'm so thankful for because it's given me the chance to talk to so many incredible people, incredible mentors, and in general, it has been such a cool experience. So I'm very happy to be here with you today. In regards to this podcast, each week I'll be interviewing one of our world-renowned mentors and asking about their profession, maybe some advice they have for the younger generations, what it means to be a mentor, and so much more. Lastly, I would just like to thank all of our listeners and sponsors for making this podcast possible. You guys are amazing and keep us going, so thank you. Now, whether you're new to this podcast or if you're coming back for another episode, I think you will love what we have in store for you today. The mentor I'm interviewing today is none other than Ralph Morrison. Ralph is a very well-known mathematician that specializes in tropical geometry. Now, tropical geometry is a relatively new field of mathematics that I don't know much about, so I'm very eager to hear all about that. He got a bachelor's degree in math from Williams College, and then he completed his PhD at UC Berkeley. Currently, Ralph has returned to teach at Williams College as an assistant professor while he is actively mentoring undergraduates through the school and, of course, mentoring through the Mentor Project. So let's give a warm welcome to Ralph, everybody. Welcome. I'm very happy to have you here today.
Thanks so much, Elise. It's great to be here.
Yeah. So just to get us started, can you tell us a little bit about yourself and how you got started in this field?
Yeah, sure thing. I've been pretty into math since I was kind of little. One of the old pieces of paper I found while digging around in my childhood home one time is me apparently having written down like 1 + 1 = 2, 2 + 2 = 4, and it looked like I made some errors, but it turned out I was just writing my sevens backwards, and I think all the math is right. So I've sort of always been excited about math. I never knew that I wanted to do it for a living until my undergrad, when I took some math courses at Williams, and there were just some really inspirational professors who sort of showed how cool and exciting math can be, how much of a creative endeavor it could be. And yeah, so from there, I sort of got more and more into the field, and now I'm excited to hopefully inspire new generations to be into mathematics.
Yeah, that's awesome. For me personally, I know I've always been pretty interested in math, and it's been one of my stronger subjects, I guess. So were you kind of that way as well? It was one of your stronger areas, or was it a bit of like a hump?
I think I was like a tiny notch stronger, which was just maybe a matter of, I think my dad told me what a square root was a little bit before we learned about it in school. So I was always like maybe a semester or two ahead of other folks. I don't think I was like throughout middle and high school and stuff. I don't think I was like, some kind of math wunderkind or anything like that. I just did math and I liked it fine, but I liked lots of other subjects too. If you'd asked me towards the end of high school, hey, what do you want to do? I might have thrown out astrophysicist or theatrical performer or something else completely different. So even though I always kind of, was into it, it was never quite that passion until I got a little older.
Yeah, that's pretty interesting. I'm kind of the same way at the moment, because I'm starting to worry about college and kind of getting that started. But I kind of am all over the place. Like I feel like I could be interested in anything, So I know I mentioned this, but can you like elaborate a little bit on what it means to specialize in tropical geometry?
Yeah, sure thing. So it's always a good icebreaker because everyone's always very intrigued by the name.
Yeah, definitely.
And so what maybe I'll say tropical mathematics first before specializing to tropical geometry. So it's an area of math where we redefine the rules of arithmetic. So we're used to addition and multiplication. So we're going to introduce tropical addition and tropical multiplication. So tropical addition is just going to take the minimum of two numbers. So now 2 + 3 is equal to 2 instead of 5. And then tropical multiplication is going to be good old-fashioned addition. So 2 × 3 is equal to 5. So 2 + 3 is 2. 2 × 3 is 5. So basically, we've taken our rules of arithmetic and just made them simpler. Because frankly, taking a minimum's way easier than I think adding things. And so, of course, the natural question is, why on earth would we do this? it turns out there are some areas of math that can be studied really nicely using these new rules of arithmetic. There's all sorts of cool optimization problems, like scheduling problems. Say you've got a bunch of airplanes coming into an airport, and people have to make gate change times, and you want to know, can everyone make their next flight out? You can solve those sorts of problems in some min plus kind of way. There's job assignment problems. Say you've got 5 people, and you have to distribute 5 jobs to them, and every person has different skill sets. So maybe person A can do job 1 a little bit easier than person B can. How do you figure out the nicest job assignment? It turns out there's again some kind of min plus thing. So originally that's why people studied these new rules of arithmetic. What I do in tropical geometry is I study the sorts of shapes that are defined using these new rules. And so, you may have seen things like taking an equation and looking at a shape that it defines, like, y equals mx plus b, that defines a line, x squared plus y squared equals 1, that defines a circle of radius 1, stuff like that. It turns out if you look at those sorts of equations and interpret everything tropically, so x squared, that's x times x, now you think of that as x plus x. And if it was x squared plus y squared, that plus is now take a minimum. It turns out that you can still think about shapes defined by these new equations. And tropical geometry is all about studying those shapes. So that's sort of the elevator pitch of what tropical geometry is all about.
Yeah. So I took geometry a couple years back, and I know that was my math class that had the most definitions and conjectures and things. So I would imagine that those are changed pretty greatly as well in tropical geometry.
A lot of them are changed, but it's remarkable how many of them still work. So one of the funnest questions to ask in tropical geometry is, hey, I know a theorem from usual geometry doesn't hold tropically. So for example, you probably in geometry saw, okay, if we've got 2 lines, they're either the same line, or they're parallel and don't intersect, or they intersect in exactly 1 point. What if it's tropical? What if we look at quote unquote tropical lines? How do those work? Do they always intersect in exactly 1 point? Can they intersect in more points? And there's some interesting fine print there. And so trying to figure out which of those theorems actually hold and which ones don't ends up being a really interesting and cool part of tropical geometry.
Yeah, that's very interesting, because like you said, you would not expect a lot of them to all be the same, because it seems like a very, very different principle to walk into math with.
It sort of seems like it should all fall apart, right? These were such bizarre operations. So the fact that everything actually works really, really nicely is sort of remarkable. And there ends up being some very deep mathematical reasons why so much stuff carries through. Turns out there's a secret process called tropicalization, whereby you take one of the shapes you're used to, like, a circle or something like that, and you can transform it into one of these tropical shapes. And it turns out that certain properties get preserved. And so then it ends up making a little more sense that you've got, certain theorems that carry through. But it's still kind of remarkable that it works as well as it does.
Yeah, definitely. So how were you first introduced to tropical geometry, I suppose, since I really have not heard of it? And when talking to my math teacher about this yesterday, he was like, I've never heard of that. So
it's a pretty young field of mathematics. I'm not sure whether I am older than it. We're about the same age, but it got started sort of in the late '80s in sort of I think a real legit way. I didn't hear about it until I was a graduate student. So I guess fall of 2010. One of my roommates, so I was starting off at UC Berkeley as a grad student. One of my roommates was organizing a seminar, a reading group on tropical geometry. And I had never heard of it, but thought it sounded cool. And he said, yeah, you should come and give one of the talks, because that's kind of how grad school works. You sort of don't know a thing, and then you have to sit down and try to read some of it and then present a talk to everybody. It's a little stressful, but it's a good way to learn stuff. So then that was the first time I ever, learned anything about tropical geometry. And it was a lot of fun. I didn't immediately get into it right then. It wasn't until a little later on in grad school that I learned a little more about it. But that was, sort of how I got introduced to it.
Gotcha.
And it is really cool kind of to be in such a new and growing field. I mean, the number of tropical geometers, I think, since the time I've joined has gone up by quite a bit. And sort of all these cool connections to other fields of math, it sort of seems like they're always being discovered. So
yeah, I'm sure it's progressing. It's a progressing field, I imagine. So I know that you are an assistant teacher as well, I think.
Yeah. So I'm an assistant professor of mathematics at Williams College. So Actually just finished teaching today. This was the last day of spring semester, and I was actually teaching a senior seminar on tropical geometry.
Yeah, that was going to be my next question. I was like, do you teach this as well? Yeah.
Yeah, and it ended up so the way I taught this was sort of as a capstone experience for our seniors. It's sort of like, they've been through a whole undergrad curriculum of mathematics, so multivariable calculus, linear algebra, abstract algebra, all these areas of math, and this is sort of for many of them the last math course they're taking. And so in a lot of ways it's a chance for them to like sort of see all the things they've seen before through a different lens. So for example, they've studied something called abstract algebra, which helps you study these sorts of polynomial equations, things like x squared plus y squared equals 1. And now they have to look at them through this different lens of tropical geometry. And, they saw, in multivariable calc, what shapes looked like in 3 dimensions. What do they look like now in this weird tropical world? So it's sort of a fun chance for them to like see things they've seen before, but that are sort of now brand new.
Yeah. Is this the only subject that you teach?
This semester it was. I teach all kinds of things, though. Last semester I taught 3 sections of multivariable calculus, which is a lot of folks. If folks have taken calculus in high school, they'll often come into college and take that. So I had something like, between my 3 sections, about 108 students, a lot of whom were first years. And being a first year this year, especially with, all of the, some students having to be remote, some being on campus, but with all sorts of, social distancing protocols. It was an interesting semester, but it was also a really fun experience to get to teach them that. And then, of course, there's lots of classes in between, so maybe the first class they take is multivariable, the last class they take is some cool senior sum like tropical, but all sorts of things in between too.
Yeah. For me personally, this year I've been online the whole year, and in regards to like my math class, I'm currently in pre-calculus. I'll be doing very well in the class, understand all the notes and everything, and because they changed the schedule to accommodate for online students, I'll come back 3 days later and be like, I don't remember this. Can we like talk? Can we go over it?
It's hard, yeah.
Yeah. So kind of with that in mind, are there any like resources or techniques for studying just in general? It doesn't necessarily have to be COVID related, that you've found works very well for like the large majority of your students, just to help other students like me?
Yeah, absolutely. I would say the number one thing is to work and study with others. This is something that took me a long time to learn. I sort of had in my head, oh, it's math homework. You're supposed to like sit down with your book and scribble furiously on pieces of paper until there's some kind of solution. And it wasn't until like halfway through undergrad that I realized, oh, wait, if I talk to other people who are working on these problems, it'll be more fun and enjoyable. I'll also figure things out faster. I'll also remember things better because it's not just all sort of me working in my own space. And so sort of, building like a group of people you can talk to and work with, I think that's super key. And of course, that was a bit challenging this past year. I was more active in like trying to get, organized, getting people put into study groups. And, for some folks that had to be via Zoom. For other folks, maybe they could, do it within pods and stuff like that. But I think maybe one of the key things is really, I guess the way I've heard people phrase it before is that mathematics is not a spectator sport, namely that you really want people to be doing math the whole time, not just listening. And also math is a team sport, namely, working with others is just going to be make it so much more fun and so much more doable.
Yeah, I definitely agree with that. I know there have been a lot of times where, whether it's me struggling in math or somebody else, just working together, it also helps to hold each other kind of accountable almost, because maybe you're like, oh yeah, I understand this, but then your friend is like, why? And then you kind of have to like do that like deeper level of thinking to make sure you fully comprehend the subject, which I always really like doing as well.
Yeah, absolutely.
So moving on to more of a mentor standpoint, obviously we've been talking about your students for the past few minutes, but have you found teaching and mentoring to be kind of two overlapping things, or are they kind of mutually exclusive?
I do think that teaching and mentoring overlap a lot. Indeed, a lot of the students who I would consider my mentees are people who I had in class, and that was originally how we met each other. To some extent, how big a course is dramatically impacts the extent
Oh,
to
I'm
which you can sort
sure.
of build those relationships with everybody. It's great when you happen to have, like a 7-person course and you can get to know everyone. And, if they are looking for support or guidance and stuff like that, you're almost automatically going to provide that. It's a lot harder when there's a lot more people, but you still do sort of start building the starts of those relationships, I think.
Yeah.
So maybe it's something that starts in a classroom, but often goes on well beyond that. So I'd say a lot of the mentoring I've done has, maybe started in the classroom, but then very much been, through doing research projects with students, whether that's working with them over the summer as part of a research program, or, doing research thesis or things like this, or even just like sort of actively being involved in students' lives after they've taken a course with you, sort of, offering advice on what directions they might take either within mathematics or other things. So.
Yeah. So would you say that when you got started with the mentor project, that was kind of like in your years of teaching before that, had you been like, I want to go into more of a mentoring standpoint, or what was your thought process with that?
Yeah, I would say that I sort of already had that, drive to be a mentor. It's in some sense it's something that almost happens organically, when you're educating people who are navigating, an important part of their lives. It's almost natural that you'll, start mentoring them in some respect. Certainly, if you lead summer research programs like I'd been doing, leading groups in them, you're almost automatically going to mentor folks. What I realized was that I kind of wanted to be more deliberate and mindful about mentoring rather than just sort of saying, oh yeah, I'll probably mentor people along the way. It's, sort of good to like kind of realize, okay, let's think, precisely about how we want to mentor, what does it mean to mentor? What are the most valuable aspects of that for people? And also for the thing that really prompted me to start getting involved with the mentor project was, sort of early on in the days of COVID, there was a lot of chaos, and there was this question of, okay, there's maybe a lot of students, whether high school students or college or middle school, who might be getting a little bit left behind now that, education has gotten so disrupted. Is there a way to more actively provide mentoring resources for students like that? And that was sort of what nudged me into starting to get involved with the mentor project, which has been a great community in terms of thinking about concrete ways to sort of think about mentoring in different ways and learn all sorts of different things ourselves and figuring out how to help others along.
Yeah. I was also going to ask you, what does it mean to you to be a mentor? But I feel like you already did a really good job of describing that within your answer to that question. So I just have a couple things left. The first one is just if somebody like me or who was my age in high school wanted to go into the field of tropical geometry, what would be the main classes that you would say to take if they had the option?
Yeah, great question. So I would say that so one of the things that's a little bit of a bummer in terms of how math is usually taught is that there tends to be this big sequence of things leading up to calculus and multivariable calculus. And it's a bummer, not because that's not really beautiful math, because it's great math. It's a little bit of a bummer because it sort of feels like, all that math is kind of, that's somehow all that math is. That there's no different flavors of math. And in fact, after multivariable calculus, that's where math sort of starts branching out, usually the way colleges teach it. And then you see all these different areas. But nonetheless, that calculus sequence is really important for this sort of thing, because you end up in multivariable calculus. And multivariable calculus, the calculus, builds up all sorts of beautiful mathematics. Multivariable calculus takes all that math and transforms it into higher dimensions. And so you're thinking a lot about things in 3-dimensional space. And that geometric understanding is really important, I think, for tropical geometry and things like that. So we're lucky in the sense that the usual sequence of calc culminating in multivariable calc, that does give you a lot of this geometric understanding of what these things look like.
Nice.
There's sort of an orthogonal area of math to calculus where you can kind of think of calculus as being continuous mathematics. And so that's, things that are continuously varying in some kind of nice, smooth way. And the other area of math is called discrete mathematics. And it's things that are, for lack of a better word, more discretized. So for example, maybe integers, like little spots on a line instead of one long continuous thing. Or problems that are finite. For instance, maybe you've got 10 computers and they're hooked up to each other with some number of network cables, and you want to study, okay, what's the fastest way to get from this computer to that computer? So it's sort of a very different flavor of math from calculus. It turns out that discrete type of math ends up being really useful for things like tropical geometry. It's also just a really fun area to study. Usually, I think this is often taught as a college course. It's in some ways like a big survey of all these different topics in mathematics that have this flavor, and also sort of introduces people to ideas of how to prove things and things along those lines. And so I would say that's also a really great one to take if you're whether or not with tropical geometry in mind. Great for tropical geometry, also great for just learning a ton of cool math.
Yeah I've been very fortunate in that. I mean, I know you mentioned that regular like public school curriculums usually go over those classes, but I've been very fortunate in the fact that the school I'm at currently, it's a private school, and they give us like complete freedom over the classes that we pick. So that's been very helpful in, I don't know, just focusing on and like honing my interests in various subjects, which has been really nice. Okay. Sorry.
Oh, no, I was just going to say, that sounds absolutely great. And indeed, a thing I wish would happen a little bit more. And, I think especially with public schools, people's hands are tied with exactly what they're allowed to teach and things. But there's so many cool topics out there that are really, really accessible and really exciting in mathematics. Things like graph theory, things like knot theory, these sorts of things where they're so visual and cool and like just a completely different flavor of math. I really wish we could work them into people seeing them a little bit earlier, just because, if people happen to not like calculus and pre-cal and that flavor of math, then, they might just decide they don't like math. When in fact, no, maybe they didn't like that little sector of math. There's all these other ones over there.
Definitely. I feel like this obviously is not the same as taking like a class in school, but with kind of the development of like the internet and how widespread it is, it's also nice that some of that is like available to students as well for free and stuff, which has been very helpful, especially if you're like specifically struggling in a subject. All right, well, it's about time to wrap up, but the last thing I had for you was just if there's anybody listening or watching who wants to contact you just about any questions or anything, how should they reach you?
Yeah, absolutely. So the probably best way to email me is through my Williams email. So that's 10rem at williams.edu. I'm happy to write that down for you later if you want to, tag it on the description or anything. That's probably the best way to get in touch with me. So just shoot me an email, and I'm happy to chat about any of these things.
All right, that sounds great. Thank you so much. This has been so much fun.
Thanks for having me.
Yeah, thank you to everyone who's listening. I hope you guys all learned as much as I did. If you want to learn more about Ralph, feel free to email him to that email. I will put that in the description. And if you want to learn more about the Mentor Project and what we do around here as a whole, you can go to mentorproject.org. I hope to see you all back here next week. Thank you so much to our listeners and sponsors for making this podcast possible.